Measures of Central Tendency, Module 2, Part 2. The objectives in this lesson are to determine the arithmetic mean of a variable from raw data, to determine the median of a variable from raw data, and to explain what it means for a statistic to be resistant. We will also determine the mode of a variable from raw data. Let's look at Objective 1. Determine the arithmetic mean of a variable from raw data. The arithmetic mean of a variable is computed by adding up all of the values of the variable in the data set and dividing by the number of observations. Almost everyone has done this at some time or another, especially if you've averaged your grades. The population arithmetic mean is computed using all the individuals in a population. The population mean is a parameter, which we discussed before. The population arithmetic mean is denoted by the Greek letter mu. The sample arithmetic mean is computed using the sample data. The sample mean is a statistic. Numbers that represent the population are parameters. Numbers that come from a sample are a statistic. The sample arithmetic mean is denoted by x bar, an x with a bar written over it. Generally, Greek letters denote parameters, which would be numbers from the population, and Roman letters, which is what our alphabet is, denote statistics from samples. If x sub 1, x sub 2, and so forth to x sub n are the n observations of a variable from a population, then the population mean mu is given by the formula mu equals the sum of all your values, all your x's, divided by the number you have. If you don't like formulas, you can just remember that to find the mean, or what you think of as an average, you add up all the data and divide by how many data values there are. If you're going to average 5 grades, you add up all of those grades and divide by 5. You will have to remember that the symbol mu stands for the population mean. If x sub 1, x sub 2 through x sub n are n observations of a variable from a sample, then the sample mean x bar is given by the sum of the x's divided by n. Notice that we use little n to represent the number of items in a sample, and capital N represented the number in the population. If we go back to the last slide. Notice the formulas are no different. If you're going to find the mean, you add up how many of whatever it is you've got and divide by how many numbers you had. The difference is whether the numbers came from the whole population or whether they're just a sample of the population. Without all the symbols, you find the mean by adding up all the items and dividing by how many you have. There's no need to memorize a formula other than to know the difference between mu and x bar. Greek letters mean population and regular letters mean sample. Computing a population mean and a sample mean. The following data represent the travel times in minutes to work for all 7 employees of a startup web development company. So notice this is all 7 employees, so this is going to be the whole population is 7. So to compute the population mean of this data, we would simply add all those numbers and divide by 7. Part B then tells you to take a simple random sample of 3 employees and compute the sample mean. Obtain a simple random sample of 3 employees and again compute the sample mean. So they want us to do a sample mean for 2 separate samples of size 3 from those 7 people. Here's the formula, and again, if you don't like symbols, all you have to do is remember if somebody tells you to find a mean, add them all up and divide by how many. So we would add up all 7 of the times and divide by 7. And that would give us an average or a mean of 24.9 minutes. And this is mu. This is a population mean because the entire population of people that work at this company is 7, and we had data from all of them. Now we're going to take a sample. And I'm going to go quickly through these slides because having a TI-84 calculator is not a requirement. If you have one and you want to know how to generate random numbers on it, then these are the slides that you might want to print and go through these steps. To obtain a simple random sample of size n equals 3, this is what we're going to do. Now the calculator generated the numbers 5, 2, and 6. You could put the numbers 1 through 7 in a hat and draw them out to get your 3. Or you could simply put the numbers themselves in there and draw out a random sample of 3. So if we're going to use subject number 5, 2, and 6, number 5 had a time of 5, 6 had a time of 26, and 2 had a time of 36. So to get that average, we would add up those three numbers and divide by 3 because we have a total of 3. Notice we're using X bar because this is a mean from a sample, and we get 22.3. If we take 3 more random numbers, and again these were generated by the calculator, but you could put all of the people back in the hat and draw out 3 more and get another random sample. Add up those 3 numbers, divide by 3, and now we have a sample mean of 28.3. So notice it's not really a big surprise that if you've got a different sample, you're going to get a different mean. What we learned from this is that the sample mean is a little bit different than the population mean, and that everyone's sample is a little bit different. Hold on to that thought. A lot of what statisticians do is use samples to predict things about populations. You can see that doing this will never give you exactly the correct information about the population, but it will be a good estimate. The point is, it is just an estimate if you use a sample. The last part of this class deals with the question of how good is that estimate? How much faith should we put in that estimate? The second objective we want to look at is to determine the median of a variable from raw data. The median of a variable is the value that lies in the middle of the data when the data has been arranged in ascending order, and we're going to use a capital M to represent the median. It's extremely important that you note arranged in ascending order. The steps for finding the median are on the next slide. Again, you don't need to worry about formulas, just order the data. If there is an odd number of data, the median is the middle data value. If there's an even number, there will be 2 middle numbers, so you average those two to find the median. So the steps for finding the median of a set of data are to arrange the data in ascending order. Then determine the number of observations you have, which they're calling little n. Determine the observation that is in the middle of the data set, and you can do this using one of the following, depending on whether you have an even number of data or an odd number of data. If the number of observations is odd, then the median is the data value that is exactly in the middle of the data set. That is, the median is the observation that lies in the n plus 1 divided by 2 position. So if you have 5 data values, then 5 plus 1 would be 6 divided by 2, so if you count over in the sorted data, your median is going to be in the 3rd position out of 5 numbers. If you have an even number of observations, then the median is going to be the mean of those 2 middle observations, because if you have an even number, just do 4 for a nice even number, then the middle is right here with no number in it. What you need to do is average those 2 that are in the middle so you get one number for your median. The following data represent the travel times in minutes to work for all 7 employees of a startup web development company. So this is the same data we had before. Now we want to determine the median of this set of data. Pause the video and see if you can find the median, and then check yourself on the next slide. The first thing you do is put the data in numerical order from smallest to largest. And notice that there are 7 observations. That's an odd number of observations. So if we add 1 to the 7 to make it 8 and divide by 2, then we will find the median in the 4th place in our ordered list. So that would be 23. So 23 is the median value for this set of data. Now we have this same startup company, but it hires a new employee. The travel time of the new employee is 70 minutes. Determine the median of the new data set. So pause the video again and work this problem, and then check yourself on the next slide. Again, we put the data in order. Now there are 8 observations. So if we add 1 to 8 and divide, we get 4.5, which tells us that the median lies between the 4th and the 5th observations. So between 23 and 26, right here, is where the median is going to be. So we need to average 23 and 26. So to average numbers, we add them up and divide by 2, and we find out that the median is 24.5 minutes. The third objective, explain what it means for a statistic to be resistant. The following data represent the travel times again for these same employees. We're going to add a new employee who has a 130-minute commute. And then we want to look at what that does to the value of the mean and the median. Again, stop the video and make your calculations before you go on. We recall from our previous work, we found that the mean before the new hire was 24.9 minutes, and the median before the new hire was 23 minutes. After the new hire, the mean went up to 38 minutes, and the median went up to 24.5 minutes. A numerical summary of data is said to be resistant if extreme values, very large or small relative to the data, do not affect its value substantially. And we had that in this case because we had a value of 130 added to our set, which was considerably larger than any of the rest of the other elements in the set. Notice in the previous example, the median did not change much. The median was 23 minutes before we added the new data value of 130, and it was 24.5 minutes after, so it went up a little but not much. However, the mean changed quite a bit. Notice our mean of 24.9, and then it went up to 38, which is a pretty big jump. Now, if you think about which one of those values most accurately reflects the average employee's commute, there are more people who are closer to the 23 or 24 minutes than there are to the 38 minutes. One could easily argue that using a median in this case would be a better representative of the data set. You may have had the misfortune to observe how one bad grade can have a pretty big effect on your grade average, which is a mean. We say the median is a resistant statistic because it is not affected very much by the addition of an extreme data value. The mean is not resistant because it is affected a lot by the addition of an extreme data value. Here's some information about the relationship between the mean and the median and the distribution shape. And remember, we talked about the distribution of data in a previous presentation. If the data is skewed left, then the mean is going to be to the left of the median, and the median is going to be a better representative number of the data. If you have symmetric data, meaning that it's pretty much bell-shaped, then your mean and your median are going to be the same. If the data is skewed right, and we said right means the tail is on the right, and it also means that the mean gets drug to the right of the median. So if data is skewed, the median is the best measure of central tendency. If the data is close to being symmetric, the mean and the median will be nearly equal, so we tend to use mean. In fact, we tend to use mean a lot when we really should be using the median. The following data represents the asking price of homes for sale in Lincoln, Nebraska. Calculator instructions for the TI-84 are on the next slide in case you have one. You can work this problem with a regular calculator. To find the median, be sure to put the data in order first, and if you have an Excel spreadsheet, sorting data in a spreadsheet is pretty quick. There's also a calculator for mean, median, and mode at this website. Again, I'm going to go through these slides quickly because if you want to calculate this, you'll need to print them off and go through on your calculator step by step. And this is what that website looks like. On the website, you would put your data in here, type it in separated by a comma. Find the mean and median. Use the mean and median to identify the shape of the distribution. Verify your result by drawing a histogram of the data. The mean asking price is $168,320 and the median asking price is $148,700. Therefore, we would conjecture that the distribution is skewed right because the mean is to the right of the median. You can also calculate many statistics at once using the following steps on the TI-83 or 84 plus models, and again you can print those out and read them. And here is a frequency graph, and you can see the tail is on the right, so it's skewed right like we conjectured. In Objective 4, determine the mode of a variable from raw data. The mode of a variable is the most frequent observation of the variable that occurs in a data set. If there is no observation that occurs with the most frequency, we say the data has no mode. If two observations occur the same number of times, we say the data has two modes, or is bimodal. If more than two observations occur the same number of times, the data has no mode. A quantitative data set, which would be numbers, will always have one mean and one median. It may or may not have a mode. A qualitative data set will not have a median or a mean because there aren't any numbers. It may or may not have a mode. An example of a qualitative data set would be a list of comments about an instructor completed on a course evaluation, such as goes too fast, explains things well, grades unfairly, goes too fast again, is too hard, is too easy, goes too fast again, is too hard. The mode of this list would be goes too fast because it is listed the most times. There is no mean or median because there are no numbers to average or to arrange and find the middle number. The data on the next slide represent the vice presidents of the United States and their state of birth. Find the mode. So we would make a list of all the states and tally the number of presidents from each state. The mode is New York because it had 8 presidents. This is just a review of the mean, median, and mode and their definitions and the formulas. And now you're ready to take Module 2, Part 2 assessment. The password is central in all lowercase letters.